Okay, so good morning, everybody.
Good morning, sir.
Good morning, sir.
Morning,
Good
sir.
Good
morning,
morning,
sir.
sir.
Okay,
Good morning,
okay.
sir.
Good morning. Let me- Okay. I think my screen is visible, but there is one problem. I'm not finding the option for recording. Maybe it is turned off or something like that.
Sir, you can check it from our what the Google Meet is running.
Where the Google Meet is running means
Means, sir, the call button, video button, voice button, screen share button in the right word.
right word. Here, actually, inside these activities, usually the recording option is available.
Yes, yes, yes,
Actually,
sir. Activity.
but you can see also there is nothing other than whiteboard. Okay, there is one problem. I don't know what is going on. Maybe they are doing some sort of maintenance work or like that. So that's why it's not currently available. Okay, let us start the class.
Sir, your screen is not visible.
Screen is not visible. Okay, check it. One
Yes,
second.
sir.
Yes,
It is
sir.
visible. And also from activity, you can see that there is no such recording option available. So I think from setting, is it possible? No.
Sir, are you not the host?
Yes, I am the host.
So you have the
Actually, last
right to
time,
record.
that is that I know, and so far I have recorded everything as per this rule, and had also done it in last day, in last class. But right now I'm not finding. Maybe it is Google has turned off it due to some reason or like that. I don't know. Whatever, maybe even if the video recording is not available, you will get the class note because I usually provide it. And if you can find any recording option, you can also find, but that recording will be stored in my Google Drive if I am the host. But this time I am not getting any option, maybe due to some maintenance work or like this is host management. All of them is stated. Okay. Chat, microphone, turn on video, meeting, access, quick access. Use external app. Right now it's not possible. There is external app, but we need to set up. and that requires some time also. I didn't know this will be the problem. Okay, and okay, class note is also good. You can, if you can consult the class note and consult some reference copies, it will be good enough at your space. Is there any function? What happened? Is there any file named function? Let me open that. I think last time I had started this. Okay, okay. Last time actually I had started with the basic introduction of the function, what function does. It's a separate unit where some task is done and the result is returned to the main unit. So this is some sort of explanation. And if you know this is enough. Now I will discuss how to write function. Okay. Let us start with adding two numbers. This is very easy to describe. So what are these? I will discuss. Firstly, write it down, or you may not have to write because I will provide this note.
Sir, the return value for the first program.
Hmm.
Sir,
Return
at the
value.
last, sir, return value of the program, first program, you have not written.
Return value for the first program.
Yes, sir.
Say in the
There
main
is
section,
in
return
the
0.
main.
Return zero, sir, at
Return
last.
zero is not required always. Sometimes it provides warning sometimes, but if you don't write, still it will execute. But at least if you write return, it runs without warning. Okay.
Okay, sir.
Now I will discuss the components of function or the parts of the function. This is one of the parts of the function known as function prototype or function declaration. Okay, let me check if the condition is same till yes. There is no possibility of recording. Function prototype or function declaration. Okay, that means when we use any function, before using, you have to tell compiler that this is the function. Actually, due to some improper handwriting or like that, it's not properly understandable. Prototype or declaration. Just we as if we write integer a at the beginning here actually. So actually we are declaring some variables. Similarly, we have to declare a function before being used. Okay. But usually this is done before main. There is one purpose. If you declare anything before main, that thing is common to every function, every uh, components of the program. So this is known as global, but you can also declare that thing inside main, but then we face a kind of restriction that that function, the function we have declared add function, that should be called always from main, not from outside main. That thing I'll discuss when I discuss scope, because right now you are not available with the scope of a variable or a function. But mind it that if it is declared outside, this function can be called from any function in the program. That's why we declare, and this declaration has three parts actually. So let us do it in separate page, otherwise it will be clumsy. There is some problem with the response in this software. So if I analyze that thing, that prototype is made of three parts actually. One is name of the function, another type of data type, better to say, data type of parameters, What is parameter? I will discuss, no problem. And data type of return value. Okay. So in our case, actually, it is integer, add, integer, integer. Actually, you are supposed to send two integer variables into the add function, and we are supposed to return one integer variable, which is nothing but the summation of these two integers. Okay. So these two are integers. That's why this is the integer comma integer. But order and numbers should be same. If your first argument is floating point, then you have to write float integer. If your last argument is floating point, first is integer, then you have to write integer float in this way. So number, order, and type of the variables should be strictly followed while declaring prototype. So this thing is nothing but the types of parameter. Okay, and this is this is nothing but the name of the function, and this is nothing but the name of the returned value. Here return value is c. It is also an integer. So actually return value sum of two integer is also an integer. So that's why return value, the function is returning some integer value, and that is declared inside the prototype. So I think in our first class we know about we we got to know about that we have to declare has include stdio.h. So stdio.h is nothing but a standard input output header file. So these header files are nothing but something that contains prototypes of the library functions. Now, what library function is? Library function is some standard functions which is already available in C language. We don't have to define the function, but like this, we have to define some functions. Okay, just wait. Okay. So that's why you try to understand the structure of the function prototype. First, we have to write return types. Since C program returns only one value, here there is no possibility of multiple data types. Just only one data type should be available. Then name of the function. Then the types of the parameter. Here there is no such limit of how many parameters it can be or how many types of parameters it can be. It can be anything. So in that particular case we are using two integer values. That's why it is integer. So this is function prototype, and this is known as function call statement. Call statement means the statement or the instruction where the function is called. Okay. Here we are passing A and B. We have taken these values from user. and we are passing these values to this function as if we are expecting that this function will add a and b and will return the sum of a and b. Okay. But problem is, if I write it in this way, will it work? That means if I just declare one function and pass two variable inside it using that syntax, I am expecting that it will add something, but will it add? I don't think so until you define what to do. So that's why the definition of function is here. This entire block is known as function definition, where we are defining what to do. Okay, what to do. Now you can see that there is a mapping of parameters. That means we are sending a and b, and these things are received by x and y. So a comes here and b comes here. So when call statement encounters, the control jumps into the function definition, it does some job, and after the execution of its job, the return statement inside the function, or even if return is not available, that is sometimes it is not true that always there will be a return. But this statement, after end of this function, better to say, the control comes back to the call statement. Okay, and then it starts executing onwards. So this is the idea behind function. It's a separate unit. You don't have to put addition. Here addition is very simple task. Just by simple operator you can do. But had it been a very complicated task, then it will very much simplify the structure of the main, because it shifts burden into another unit, and that is very useful approach for any type of programming, because if you make it clumsy, then it is very difficult to debug. And not only that, if there is any error or like that, you have to rectify everything, but rather if there is any error or if you like any modification, if you do this in your function, that will be reflected here. Okay. So z is, it's returning the value as z, and z comes here actually. Z comes here actually as a return of this function, and it is being assigned to C. So here I can say that x equal to, sorry, it's not right in this way. This statement is equivalent to x equal to A and y equal to B. And this statement is equivalent to C equal to Z. That means the value returned by the Z, it is not C equal to Z exactly, because when the function returns, these variables are deallocated from the memory, because these variables, the x, y, z, that is whatever declared inside the function, these variables are called the local variables, or the variables local to function add. Okay. So these variables do not exist after the return. So actually the value returned by z, it is copied into C. Okay. So try to understand the mechanism, then I will get into the detail of that thing. The control was starting from here, then after scanf, the control jumps into the function definition or function. This is the function definition where this A is copied to X, B is copied to Y. So X contains what is the value of A? Say, let's say user gives A equal to 10 and b equal to 20, like that. So here actually x becomes 20, x becomes 10 and y becomes 20, and after addition z becomes 30. So that 30 is returned and 30 is assigned to c. So it is equivalent to c equal to 30, like this. And now I am printing the value of c, and from this function I can visualize in this way that I have supplied 10 and 20, and as a return we are getting 30 from the function. But here actually you see the internal mechanism inside it, x and y, then z is the local to this function, x plus y equal to z. So I think here you can understand. And then we are returning or sending the value back into the function. Okay. So control, when control is shifted to the function, this is known as function call, and when the control is shifted back into the calling function, this is known as return. Okay. So here actually in under this scenario, main is calling add function, or better to say I should not use that thing because that is technically incorrect. It is actually sending the sum of this. So this is known as calling function, and this is known as called function. If there are multiple functions, let's say f1, f2, f3, f4 in this way, so it calls it, then it may also call this function, after that it will get return, it may send return value. So here actually if you analyze which calling and which called function, this is calling function and this is called function, and this is called function, this is called function, but this is also calling function because it's calling f3 and f4. So a function can be called or calling, both. Okay, can be both calling and called. So this is the calling and called relationship. Okay, so up to this, any problem to understand?
No, sir, understood.
No. Okay. Okay. So I think I'm repeating once again. Before using any function, we have to declare the type of the function, or then it includes name of the function, type of its input parameters, and type of the return value. That is, that together the syntax is known as function prototype or declaration. And inside the calling function, you use this terminology while discussion. There will be a call statement. If encounters, the control jumps into the function definition where some processing is done, and after processing it returns some value that is received by the calling function. And this is not always true because there are some functions which does not return any value, or which does not send any parameter into another value. That is also possible. I will show this type of cases one by one, but this is the normal understanding of function mechanism. Okay. So here main is calling function and add is called function. Okay. Now let me discuss two issues. One is library function. Another is user defined function. Actually, the library function is already available. You don't have to define. Example is printf. You are not defining printf, you are directly using scanf, pow function. These are library functions. But user defined function is defined by user or developed by user. These are not already available. Okay. Here actually I had defined one function, name is add. So I'm not providing any example, but because when you have to provide example, you have to write the code for it, because user defined functions are not standard functions available in C library. So I cannot give you a name of that function, because name is chosen by the user or the developer. So just I know the concept. Okay. Types of functions. Actually, functions are of four types. What we have seen in the prototype, there are three types. One is uh, parameter, name of the function, and return value. These three are the basic structure of a function, call statement, and prototype construction. So here also you can see that after the name of the function, we are supplying multiple arguments. Okay, it not necessarily it is two. It depends on type of the application. So here you find that integer at int, these are the prototypes of these two, and here actually this is received by integer x and integer y. So if you commit any mistake, the C program will throw an error, that type mismatch error. That means this type, the type of this variable and type of this variable, this should be same always. Similarly, type of this, data type of this, data type of this variable, and data type of this. These three should be same. Otherwise, compiler throws type mismatch error. Okay. So depending on these three elements, that name is fixed always. There is no such problem with the name. So I'm discarding this part. Actually, depending on these two, parameter and return value, functions are of 4 types. Okay. With I should not write in this way because it will make the thing very clumsy. Rather than I will make it drop down. Okay. With argument, what is argument? Parameter is alternatively called an argument. List of parameter or argument. And one thing I just have forgotten to mention that these arguments are also available here and here. So the arguments in the call statement, they are known as arguments in call statement, they are known as actual argument. And arguments in function definition, they are known as formal arguments. So don't miss out these terminologies, because when you write any example or any description about a function, you have to write in this way: function, prototype, declaration, call statement, actual argument, further argument, type of parameters, return type. So in this way, actually, you have to use this terminology. So don't get confused. Okay. So actual argument during function call, actual arguments, all of the actual arguments are copied into corresponding formal arguments. Okay. But here you keep in mind that these things should not be always different, because here I can also use A and B instead of X and Y, but these A and B are not same as this A and B, because these A and B's are the separate variables and available only within this add function. That these variables are not available inside main function or calling function. So initially you need some time to understand the concept. So that's why I'm sticking to basic again and again. But once you understand the basic, I can very easily switch over to the advanced topic. Okay. With argument, with return value. Then without argument, with return value. With argument, without return value, and without argument, without return value. Okay. So these are the types of functions. These are the types of functions. Now, what is with argument with return value? That means function will pass argument or send argument into calling function will send argument into the called function. Called function receives an argument. After operation, called function returns some value to calling function. So that is what we have seen so far. This is the ideal scenario of function. That means with argument, with return value. Function has some arguments and function is returning value. Okay. So this first case is itself I have discussed. I have discussed the first case already with argument, with argument. But the function, what will be the prototype? Prototype does not require any argument. Okay. So when there is no argument, you have to write void. Okay.
Sir, break.
Break. What is break here?
It's a 10-minute break.
Oh, break for 10 minutes. Actually, I thought of break statement. Okay, you may take break. Okay, back after the break. Why is it without argument and with return value? If you look at this prototype, there is no such argument, that's why it is void. And in call statement, you will notice also, because in these three areas, you will get the idea what type of function we are using. And in function definition, these lines should match with the prototype and call statement. Here, since there is no such argument, it is void. And so, but addition requires argument. Without argument, you cannot add two numbers. Without operand, you cannot add two numbers. So, this argument will be taken directly inside the function from the user. So, that's why your calling function doesn't need to supply any argument to the called function. So here we are taking arguments here, the values of the arguments x and y, and after addition, it's getting the result. Okay. So that's why this type of function is without argument but with return value. Any problem to understand this?
No, sir.
No. Actually, it's not very difficult things. And the next one is with argument without return value. Is it? We already discussed with argument without return value. That means there will be an argument, but that's is not the function is not returning anything. With argument, then that means there will be an argument, but it's not returning. That means return type of the function is void. Since it's not returning anything, it's not receiving. Yeah. If you see the difference between this statement and this call statement, so here actually there is a scope for assignment because these values returned by the function and that is being assigned to other variable. But Here there is no such scope because the function is not returning any value. Actually, there is some problem with the slide. The blank slide comes here. So, let's check it. Okay, so this one is discussed. With argument, without argument, with return. What is the slide? We have to print directly here from the function. We can't afford to send it. After this statement, the control will return automatically without value. Okay. So after this statement, the control comes into the definition of the function, and after this statement, control returns here. Okay. But it's not printing anything at all. So that's why this is with argument without return value. Okay, you will get the same output, but the structure of the function is not same. Okay. So always focus on these parts, this statement, this statement. Using these parts, you can very easily identify what kind of function is it. It is. What kind of function it is, you can very easily identify. Any problem to understand this?
No, sir.
No. The last one is without argument, without return value. So what does it mean by it? Or how do we write? So void add void. This much is only required here. Just you have to call in, and we are shifting the all sort of burden of taking input collection from user and introducing values to user into different unit. That is the add function. So if I look at the prototype, this is like this: call statement and the function definition. You will notice that we haven't taken any input and we are not returning any value. When this statement encounter, control comes into here, and after that control comes back into this line, and then it starts executing onwards. Okay, but everything is shifted into a unit, even input taking and printing output. Okay. So these are the 4 types of functions. This is the type number 4. So if you have any problem in with this type of approach, you please tell me. If you don't have any problem, then I will switch over to another issue. Okay. Hopefully you don't have any problem. So let us move on to another type of special function, which is known as recursive function. Recursive function is a type of function that calls itself. Okay, calls itself. That means inside, let's say your function is f1 like that, or f. Inside your function, there is a call statement of f. So this type of function is recursive. So let me provide one example with this. We know, do you know how to calculate factorial? That means using function. What is the definition of it? Factorial 1, 2, 3 in this way up to n. Now I can also write the definition in this way: factorial of n. So if it is factorial 1, then it is 1. If it is factorial 2, then it is 1 into 2. If it is factorial n, then 1, sorry, this is n is already I have mentioned. If it is factorial n minus 1, then it is 1, 2, dot, dot, n minus 1. So actually factorial n is nothing but factorial n minus 1 into n. Do you know this relation from mathematics? Do you know it?
Yes, sir.
Yes, sir.
So using this relation, I am writing this: factorial n equal to n multiplied by factorial n minus 1, and if your n is 0, then it should be 0, and it should be negative. That is not true actually. if your n is 0, it should not be fact minus 1, because factorial of minus 1 is undefined. Factorial of negative number is not defined, so it can be 1 if n equal to 0, and this is for n greater than 0. Any doubt with this definition? Any doubt do you have?
No, sir.
No.
Sir, why we are using FSCT? Why you are not using the exclamatory sign?
Actually it is exclamatory sign. The function is same, but since I am trying to organize it like a mathematical function, that in mathematical function you write fx like this, y equal to fx. So in this way actually, because ultimately you have to map it into function. Okay.
Okay, sir.
Factorial n actually I am writing in this way. It's also a function of n.
Yes, sir.
Now I am writing or developing a function only. I am not developing the main body. Main I am going to discuss later. Let's say the return of the factorial, its input is 1 n actually, and return is factorial n. Okay, this should be the return of the factorial function. So when we define factorial, it should be like this. This is name, no problem, and this is also one input. Instead of n, I am written x here, because since it is formal, I can take any name here. Now, if x equal to 0, let's say I take one integer here, result r equal to 1, else r equal to x multiplied by fact x minus 1, is it?
Yes, sir.
Then return r. We can also write the program in different ways. That means we can directly send it as a return, but it will be much easier for you to understand since you are the beginners. Okay. So now from main, what I can do, if I can ask user about enter value, user supplies the value, and that will be stored in some variable. I haven't declared it. I have to declare. Now let's say s. I'm taking another variable which will hold the value coming from this function. So n, I'm supplying this, and now this is. So far I haven't written the prototype. Prototype should be, it has some parameter and return value. So it should be like this. Okay. So look at these three things. if there is any scope for type mismatch. No scope, I think. So if you look at the function, that fact function is calling fact within its body. Okay. So this type of function is recursive. This a function is calling itself. It calling it calls itself. So you can also develop any other type of function that is also recursive. But before that, you have to develop the recursive definition of something, some execution. Let's say you are adding some natural numbers, 1, 2, 3, in this way also. So you can also visualize it as a recursive way because it is up to the sum of n plus 1 and then n. Okay. So if I write sum up to n is nothing but sum up to n minus 1 plus n. Okay. And if it is 0, then it is 0. So in this way, if you recursively define the sum of natural numbers, n natural numbers, then you can also develop a function and where you need to call the, the same function within its body. Okay. There are lots of discussions can be done with recursion, but I am not getting into that kind of complication because we are learning this type of things for the first time. Better I provide you some guidelines of using this type of function. And there is one standard representation of this function, that calling and call relationship, that is known as structure chart. In structure chart, we have to decompose our program into several functions. Let's say in this case, I am actually one function is sum, another is main. So it is sending one argument. Actually, this function is a little complicated. I can show it also later because there is some loop inside it. Let us consider the scenario of addition. It will be much easier for you to understand. This function can also be done. Addition. For addition, we had used one main and one add function. If it is the first type, then with argument without return, then it will be like this. So I had also used structure chart, but the term or the formalism maybe it is new to you. So I will show you more examples of this structure chart. Let me check if it is available online or not. Structure chart. Actually, before doing any type of application, if you do the same thing, if you draw the structure chart, it will be easier for you to understand. So actually, this type of things are very complicated and not for your use, but try to understand the idea first. that here is one function. It is being decomposed into three separate functions, and these functions are also being decomposed. So in this way, actually, the calling and call relationship is maintained, and ultimately the value comes back into the function. And you don't have to understand the meaning of these, because these are some units for separate applications. Here also you can find that there is one function. It is calling a function. It is also calling this function, and these two functions are returning values to it. Okay. So when your application is complicated, then and you need to divide your application into multiple functions. So if you maintain a structure chart, it will be easier for you to design each of the units separately. So here actually you can say that a very simple example of structure chart. One main, this function is computing average, and this function is just printing hello. Okay. So it's sending A and B, it's returning average value, and it's not actually sending, it's just calling. I think it will be clear to you. So before dealing with any type of function, I think it will be much better for you to draw a structure chart on your paper. Okay. Then it will be easier for you. Last time I had discussed the computation of NCR type of thing. So in this structure chart, you will find that main is sending this, and NCR is also sending something into it. It's returning some value, it's also returning value to the main function. So if you know this structure chart, then you can develop factorial as a separate unit, you can develop NCR as a separate unit, you can develop main, and you can call set your call statements accordingly. So if you have this diagram, it will be easier for you to manipulate with any type of function and do some modification. You can clearly understand what is going on. Okay. Rather than putting everything into a function, because it makes your function development is very clumsy, and not only that, everything is not under your control, because uh, here actually you can find what is going on from the diagram. But if you don't draw a structure chart, then still it will be the confusion that which one should be kept in a function, which one should be kept in main, or which one should be available where, and who will call this function. In this way, that calling and call relationship, there will be a confusion regarding this. Okay. So I suggest everybody to maintain at least a brief structure chart before dealing with any function in lab. Okay. But that is not mandatory. If you are confident that without this diagram you can do so, it's not a big issue. You can do it. But since you are the beginner, if you can use this diagram, then it will be much better. How much time is left? I think 10:30. Yeah, still there is time. And in this type of recursive problem, actually there will be a loop in our structure chart. That means it will keep calling the same function, I think, again and again. pointer is a variable that holds because there are some parts of a function which requires the knowledge of pointer. So if I don't discuss, maybe you cannot understand the thing. So I need to discuss briefly because pointer is not so easy in C programming because there are lots of complications regarding pointers. Even you can find by Y connector there is a dedicated book pointer in C, not letter C. Okay. But I am not focusing on this part. I am actually focusing on address, the basic things regarding pointer. What's the address of another variable? Okay. Now, what does it mean by it? If I declare one variable, let's say a equal to 10. So if I print the value of then a becomes 10 because memory layout you will find a is a variable which contains 10. So if I print then surely we will get a here, sorry 10 here, no problem. But in pointer, using pointer, I can set the address instead of value. I can set the address of a variable into another variable such that through that address you can directly access the pointer, access the variable. Okay, without its name, you can also call by its address. Okay, not by its name. We are actually calling by name, but we can also call it by its address. Now, pointer is declared in this way. Okay, integer star p. P is the name of the pointer, like a, like b. P is also a name of the pointer. Okay, but this star symbol should be given before writing pointer variable. Okay, so this is pointer variable. This is pointer data type or pointer, the address of the data type held by pointer variable. The data type what should be the correct? The data type of the variable whose address is held by p. Actually, together we'll call p as a integer pointer. Because p is a variable, pointer variable that holds the address of another integer variable. Now, how is it possible? In next line, if I write p equal to ampersand a, then what does it mean by p is a variable pointer which holds the address of A. Okay, that means it is pointing A. Now what happens? Instead of printf %a, if I write printf %d star p, then it will also print a. Star p means content of the variable whose address is held by p. Okay, in that case the value is a. Sorry, value is address of a. So here we will also get the same result, that means 10. It's not printing this content, it is printing the content whose address is available inside P. Content of the variable. Okay. Any problem to understand this concept? If you have any problem, please tell me, because this
No,
is
sir.
little bit. Okay. No, sir. The pointer can be more and more complicated. That means I have written integer pointer to integer. It should be integer. Instead of integer pointer, it will be much better, because next what I am going to deal with, you will get the advantage. Pointer to integer. Now let's say we take another pointer, integer star q. What is it?
So it's a pointer for the pointer.
Exactly. Pointer to pointer to integer. That means it holds the address of another pointer. The pointer is a variable, so this variable can also be a pointer. So here you notice that statement. There is some problem. Let's say q equal to ampersand p. So it means q is holding the address of p. Now if I write star q, so star q means the content of the variable whose address is available, that means nothing but ampersand a, and star of that is nothing but a. Actually this star and ampersand, these operate in reverse order. Okay, this operate in reverse, that means star actually cancels out ampersand. Okay, star represents the content of the address available at some variable. Okay, so here actually we are dealing with ampersand p. So ampersand p means nothing but ampersand a, so it is nothing but ampersand a. And similarly, if you place two star before it, so it cancels out these two things, so it becomes address of a value of a. So here also we'll get the content of a. So these three representations are very important. This syntax, this syntax, this syntax, this syntax, and the applications are this. Okay. So don't forget about it. This example is very explanatory. If you don't understand, please tell me. And not necessarily pointer can be used to hold only the integer value. It can be used to hold the floating point character. It can be pointer to character, pointer to character, point even. You can also use multiple indirection like star, 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 star in this way. If your application demands, then pointer to in this way up to integer or floating point or whatever. You read it carefully, go through it carefully, and check if you have any doubt in it. Because if you have a doubt in it, then I cannot properly explain the rest of the part. Okay, or maybe you will not understand properly.
Percentage.
Your voice is not properly audible. If you can repeat your question.
Sir, or ampersand and star reverse operations.
Reverse operations. Ampersand and star are reverse operations. As a result, if you can visualize it, Q means it is ampersand P. So one ampersand and one star, if it cancels out, it becomes P. So star P means ampersand A. So this ampersand and this star cancels out, and finally it becomes A. So actually we are printing the value of A. So these two statements are equivalent if your
Yeah.
data structure is like this. Understood or not?
Understood, sir.
Okay. How much time is left? Only it shows 10:46. Is it?
Yes, sir.
Yes, sir.
Okay. Then only 3 to 4 minutes are left. So maybe I should not continue because it requires some time. So next day I will continue rest of the parts.